हाय एवरीवन। आज हम लोग स्टार्ट करने वाले हैं सम इंट्रोडक्टरी पार्ट ऑफ द अप्लाइड बायोमैकेनिक्स, राइट? सो लेट्स स्टार्ट. If I'm talking about applied biomechanics, so first of all, I need to know what is meant by biomechanics, right? So biomechanics is the study of the structure, function, and motion of any biological system, okay, such as humans, animals, cells, okay, by applying the principles of mechanics and physics. जब भी हम mechanics और physics के principles किसी भी biological system पे लगाते हैं, may it be living organism, चाहे वो humans हो, animals हो, cells हो, then we consider that term as biomechanics, right? That branch is known as biomechanics, okay? So what does it do? It analyzes how internal and external forces like gravity, muscle contraction, they all affect the movement, right? They affect the performance. How is the injury caused? By bridging the biology and the engineering, okay? So whatever type of movements are being performed in a in any biological system, वो चीजें कैसे कोई इंजरी कॉज करती हैं, वो चीजें कैसे किसी मूवमेंट को अफेक्ट करती हैं, हाउ इज द परफॉर्मेंस बेस्ड ऑन दैट, राइट? इट विल एनालाइज ऑल दोस पार्ट्स, राइट? But if I'm talking about the word kinesiology, or if I'm talking about the term kinesiology, right? Kinesiology specifically is the scientific study of human movement evaluation, right? जब भी हम humans का movement का evaluation करते हैं, right? How are our muscles acting? What is the gravity having the force on our muscle? Okay. What is the torque? What is compressive force? What is bending force? What are the changes that it is leading to? जब भी हम ये सारी चीजों का analysis only human movement के perspective से करते हैं, basically that is known as kinesiology. Okay. So it is an umbrella term used to describe any form of anatomical, physiological, psychological, or mechanical human movement evaluation. Right? Now, we need to consider some difference between kinematics and kinetics, right? Just remember the word kinematics is having a letter M in it, right? So anything related to movement, M for movement, and M is also there. The letter M is also there in the kinematics, right? So anything related to movement, right? What was the angle of the movement, around which axis the movement is occurring, in which plane the movement is occurring, what is the speed of the movement, okay? Any characteristic of the movement, right? It is concerned with the characteristics of the motion, okay, from a temporal perspective, without reference to the forces causing the movement, right? Irrespective of the forces जो वो movement करा रही है, right? We only need to know the characteristics of the movement. वो मोशन का एंगल कैसा था, टॉर्क कहाँ बना, मोमेंट आर्म कितना था, कौन से प्लेन में मूवमेंट हुआ था, कौन सी एक्सिस के अराउंड मूवमेंट हुआ था, ये सारी चीजें जब हम मिला के एक ह्यूमन मूवमेंट का एनालिसिस करते हैं, दैट विल कम अंडर काइनेमैटिक्स, ओके? So, a kinematic analysis involves the description of movement to determine how fast an object is moving, how high is it going, or how far is it traveling. Okay. So, what are the components of kinematics? The position of the movement, the velocity of the movement, and the acceleration of the movement. Okay. But if I'm talking about kinetics, right? Kinetics is just referring to the forces causing the movement. What was the reason that this movement occurred at such a high pace, at such far level, or at this angle or velocity? Okay, so what was the reason for that movement? So reasons are the muscle pull, the gravity, okay, all these things. Okay, so kinetics is the area of study that examines the forces acting on a system. Okay, so it will always examine the forces causing a movement. It may be gravity, it may be muscular pull, it may be ligamental pull, it may be, pressure due to, pressure due to ground reaction forces or anything. Okay, so that will all come under kinetics. Now, after that, we need to consider some types of motion, right? There are different types of motion that occur in our body, okay? So first is the translatory motion, a rotatory motion, and a general motion. Now, if I'm talking about translatory motion, right? Translatory motion leading to translation, basically something moving at a, at a normal pace, something moving in uniformity, something moving in a straight line. Okay, so a movement of a segment in a straight line. Okay, translatory motion means movement of a segment in a straight line. Okay, so in a true translatory motion, each point in the segment moves through the same distance at the same amount of time, usually in parallel paths. Okay, so for example, if I'm having a runner or a sprinter and he is moving or he is doing the sprinting, okay, so every part of his body, his head, his neck, his torso, his abdomen, his pelvis, ankle, everything is moving the same distance at the same amount of time. They're traveling the same distance in the same amount of time. Okay, it never happens that his head will go first, then after 2 seconds his abdomen will follow, then after 3 seconds his leg will follow, right? He is moving as one whole object. Okay, so whenever all the object, all the parts of the object or the body are moving the same distance in the same amount of time, that motion usually in human movement evaluation is known as a translatory or a linear motion. Okay, but if I'm talking about a rotatory motion, okay, so movement of a segment around a fixed axis, right? Our earth also rotates around a fixed axis, right? So whenever there is a center of rotation in a curved path, okay, and something moves around that, okay, that is known as a rotatory motion. Okay, so just remember, like our earth moves around its axis or rotates around its axis, right? So in a true rotatory motion, each point of the segment moves through the same angle at the same time at a constant distance from the center of center of rotation. Okay, so for example, if there is a gymnast and she is doing a 360-degree complete flip. Okay, she is holding the pole and she is doing a complete 360-degree flip. So the amount of angle that her wrists are moving, okay, they are also 360-degree, and the amount of angle her feet are moving are also 360-degree. Okay, but there is a difference between the amount of distance her feet is traveling as compared to her wrist, right? Her wrists are moving only this much, but the feet of that lady or feet of that girl is needing to complete the whole 360-degree arc, right? So that is the angular motion. Okay, that means different parts of the body are traveling different distances in the same amount of time. So that is the rotatory motion, right? Similarly, for example, if I'm talking about the shoulder abduction, right? So my whole humerus is here, right? It is one whole object, right? This is the head of the humerus, this is the shaft, these are the epicondyles, the condylar area, okay? But whenever I need to move my shoulder into abduction, the head of the humerus is traveling only this much distance, okay? The shaft is traveling this much distance, but the condylar area is traveling this much distance. Okay, so all the parts of the one object, okay, all the body parts of one object are traveling different distances in the same amount of time, right? So that is known as a rotatory or an angular motion, right? And maximum number of movements that occur in our body are angular in nature, are rotatory in nature. Okay, then comes the third type of movement, which is a general motion. Okay, so it occurs in a curvilinear plane. Okay, and it designates a combination of translational and a rotational motion of a segment in two dimensions, right? So the axis about which the segment moves is not fixed, but it shifts the space as the object moves. Okay, so a combination of translatory and a curvilinear or a rotatory motion is the general motion. Now, after that, we come to some displacement in the space, right? What is center of mass, what is center of gravity, what is line of gravity and everything, right? So we know, we have all heard about center of mass, right? What is center of mass? The center of mass is a unique point representing average position of all parts of the system or an object at one point. Okay, where the entire mass of the body is assumed to be concentrated, okay, for studying the translational motion. Okay, so if I'm holding the object from its center of mass and I'm keeping it stable, okay, the body or the object cannot fall in any direction, right? Because there is a proper equilibrium maintained at the center of mass. Okay, so it acts as the balance point for an object in free motion. Okay, but if I'm talking about the center of gravity, this just remember by the name, okay, center of gravity, where the gravity is acting. Okay, so the center of gravity is a theoretical average point where the total weight of the object is considered to be, considered to be balanced or considered to act. Okay, so it acts as a balance point where gravitational torque equals to zero. That means if I'm holding that object or that person or that body from the center of gravity, okay, and it is being stabilized, it won't fall down due to pull of gravity or torque of gravity. Okay, so a lower and more central center of gravity will increase the stability, whereas a higher object is likely to tip over. Okay, because as the center of gravity moves higher, equilibrium will decrease, stability will decrease, and there are high chances that more gravity will act on the object and the object will tend to fall down due to the pull of gravity. Okay, and then comes the line of gravity. Okay, so what is the line of gravity? The imaginary vertical line passing through the center of gravity is called the line of gravity. Now we come to some planes and axes. Okay, so we know that any motion in our body occurs around three axes and in three different planes. Okay, so any motion which is occurring around something, that is the axis for movement. Okay, and any motion which is occurring inside something is a plane for movement. Okay, for example, if I'm standing in a empty room, okay, and I have a pole just in between that room. Okay, so if I'm just rotating around that pole will be my axis of rotation or my axis for movement. Okay, but if I'm allowed to go into any corner in that room and at any at any space in that room, right, so that room becomes my plane for movement, inside which I can move, inside which I can do the movement, but around that pole will be my axis for movement. Okay, so while we are considering any human movement, we consider there are three planes of movement and three axes of movement. Okay, so what are the three planes of movement? The sagittal plane, the frontal plane, and the transverse plane. Okay, now how can I remember these three planes? Just remember that if I am doing a middle partition over here, okay, consider the skull. Okay, so if I'm doing a middle partition, so that middle partition will be symbolizing the sagittal suture of my skull, that is dividing my body or my skull into left and right halves. Okay, so just considering that plane through the sagittal suture, okay, the plane that divides my body into two equal right and left halves is the sagittal plane. Okay, and the movement that occurs inside the sagittal plane is the one which you can observe clearly from the side view. Sagittal plane, side view. Okay, so if I'm considering and if I tell you or if I ask you that can you see my shoulder movement, flexion and extension properly from the side view, you'll say yes, ma'am. Okay, so just remember that flexion and extension occurs in the sagittal plane around the frontal axis. Okay, because each plane and axis are perpendicular to each other. Okay, so movement occurring in sagittal plane cannot occur around the sagittal axis. It will occur in the around the axis that is lying parallel or that is just lying like the sagittal plane. Okay, second is the frontal plane. Okay, so if I'm wearing a hairband like this, it is coming like this. Okay, so representing the hairband is my coronal or coronal suture of the skull. Okay, so coronal plane is also known as frontal plane. Okay, so any plane considering like this, coming parallel like this, which is dividing my body into two equal anterior and posterior parts, is my frontal plane of movement. Okay, and the frontal plane of movement occurs abduction and adduction movements, okay, which are occurring around the sagittal axis. Okay, and the transverse plane, we know that it is going just by my umbilicus, dividing my body into upper and lower two equal halves, and just perpendicular to that will be the vertical or the horizontal axis. Okay, so usually translatory or rotatory motions, we will say that they occur around the transverse plane. Okay, now see over here also, we mentioned the same thing, that in the sagittal plane, it is a vertical anatomical plane running from running from front to back, dividing the body into left and right sections. Okay, and it enables forward and backward movements like flexion and extension. Okay, for example, walking, for example, doing bicep curls. Okay, then we come to frontal plane. So the frontal or the coronal plane is a vertical anatomical plane that will divide my body into two anterior and posterior halves. Okay, and it is the plane of lateral or side to side motion, that is abduction, adduction. Okay, and lateral flexion around the anterior-posterior axis or the sagittal axis. Okay, and the key movements include side lunges, jumping jacks, shoulder raises, everything. And then comes a transverse plane, right? So the transverse plane or the axial horizontal plane will be the imaginary line dividing the body horizontally into superior and inferior halves. Superior and inferior parts, okay? And running parallel to the ground, this plane is essential for describing rotational, twisting, horizontal movements such as spinal rotation, hip rotation, or horizontal abduction and adduction. Okay, so these were our three planes of motion. Okay, and these were our three axes in which our human movement occurs.